Okay, so for this last section of the semester, section 9.6, this is an important one. It's the Pythagorean Theorem. Once again, for this particular worksheet right here, we're only going to worry about the Pythagorean Theorem. We do not solve for radical equations. You'll do that in college algebra. You move on. I don't know, or in some other math class. So part 3 is not going to apply to us. Only part 1 and part 2. Alright, so let's go ahead and discuss the Pythagorean Theorem. The Pythagorean Theorem is essentially trying to figure out the sides of any triangle. Now, you're going to have to get provided at least 2 sides. So this is the generic form of the Pythagorean Theorem. You have a squared plus b squared equals c squared. In other words, if you to square these two and you add them, they give you the longest side, which is the c. Now, these two are known as your legs. And this side right here is known as your hypotenuse. Now keep this in mind. When we're dealing with this will always be the longest side, the hypotenuse, and it'll always face that 90-degree angle. So you can't lose yourself. It's going to be the opposite way. These two are interchangeable, so it doesn't really matter whether it's A or B that you're solving for. But this one, you should never mistake it. This one is always the longest side. Now in our worksheet, they didn't provide us an example of how to do that with a triangle. So here I'm giving you one right there. So they're giving us our 2 legs, the measurement of our 2 legs, which is 6 feet and 8 feet. And trying to figure out the hypotenuse, which is c. So once again, let's start off with the Pythagorean Theorem itself. Now remember, this only applies to right triangles. It does not apply to any other type of triangles. A right triangle always has that little square right there to denote that it's 90 degrees. So, following the order that you have here, A here is 8. And once again, you're going to square that. And you could omit the feet. We'll put them on later on. The B would be 6, so we're going to square that. And since we don't know C, that's what we're trying to solve for. So, first of all, square it. And if you have section 9.1, remember your perfect squares, that's the list right here. So, 8 square. 8 square is 8 times 8, which is what? 64. Once again, at this moment, you should already know these. 6 square, 6 times 6 will be 36, equals c squared. So far, so good. Alright, so now we're going to go ahead and add those two. 64 and 36, that'll give you 100, equals c squared. But remember, we're looking for c. So we got to get rid of that square. To get rid of that square, we're going to go ahead and take the square root of both sides. We're going to take the square root of c squared, and we're also going to take the square root of 100. Alright, so the square root of c squared will just simply be c. And the square root of 100, we already know that if we square 10 times 10, that'll give you 100. So it'll just simply be 10. And that would be your answer right there. C equals 10. So once again, not too difficult. But sometimes they're not going to give you the triangle. Sometimes they're just going to be straightforward. For example, letter C. Letter C, they're already giving you what A and C are. They want you to find B. So in some of the questions that you're going to have for this, they're going to be as straightforward as that. So once again, always start off with the Pythagorean Theorem. We're going to substitute A, which is 9. We're solving for B, so it's B squared equals C squared, which is 15. We're going to substitute 15 for C. Now notice the difference here. Here we're not solving for the hypotenuse. We already know it, and we know one of the legs. So we're trying to figure out one of the other legs. Once again, you don't need the triangle for this because they already provided those things for you right there. 9 squared is 81 plus b squared. 15 squared, which is 225, 15 times 15. But instead of adding like you did right here, we're going to solve for b squared here. So we need to isolate it. So we need to subtract 81 to the other side. So it's a tad different from our previous one. And let me go ahead and move the work up here. So now we have b squared by itself. And we're going to go ahead and subtract 225 from 81. Which gives us 144. So once again, 225 minus 81 gives us 144. Once again, we got to solve for b because this is b squared. So to get rid of a square, we need to take the square root of it. So we take the square root of b squared and we take the square root of 144. And we know 144 is a perfect square, so b equals 12. So it's a very simple problem right there. So once again, put attention to what you have right there. Sometimes you're going to have to add, sometimes you're going to have to subtract. Let's try another one. Letter D. So once again, you start off with the Pythagorean theorem itself. Now they're giving you B and C, so we're trying to find A. So we don't have A. We're substituting B. Now notice that this has a square root. So that's important right there. Square root of 3 square. And the same thing with C. Square root of 8 square. So it's going to be different from our previous ones. Our previous ones were whole numbers. Here we have square roots. We have radicals for them. So this will be a squared. So let's do a little bit of work over here on the side on what this becomes. So what does square root of 3 squared become? Well, remember, we're squaring that. So essentially what you're saying here is square root of 3 times square root of 3. If you multiply these two, square root of 3 times square root of 3, that gives you square root of 9. And what is square root of 9? Square root of 9 is 3. So essentially what happens when you square a square root, what we have here, we end up with what's on the inside. So the same thing here. If we were to square the square root of 8, remember that square root of 8 times square root of 8, which is going to give us the square root of 64. And the square root of 64 is just simply 8. So it gives us that. So once again, it's a little bit different from our previous one, so put special attention to your values here. Everything else is the same. We got to solve for A, so we got to get rid of that 3. So we subtract 3. So you got A squared equals to 5. Once again, we cannot leave it with the A squared right there. So we're going to take the square root of A squared and the square root of 5. Now in this particular case, they want it as an exact into radical form. If you read the instructions right here, they want your answer in radical form. So you're not going to use your calculators to get the square root of 5. You're simply just going to leave it as square root of 5. And that would be your answer right there. Alright, so this pretty much concludes part 1 of section 9.6. In a little bit, we'll do part 2.